Kia ora Year 9. This is part 3 going over the JAF measurement practice. I'm going to start in at about question 15, which is this one here. So in part 2, I've got up to question B, but I didn't get time to finish it off. So I'm going to go through it here now. So the final answer that we should get to is 438 centimetres squared, but I want to look at how we can work up to that point. So when you get to these harder questions, it's really important that you show us what you're thinking. It's not just about getting that final answer of 438 centimetres squared. We want to understand how you did it. So one thing that I like to do is to break up composite areas like this into several parts. And then to make it really clear what I'm doing, I label them 1, 2, and 3, or here I'm going to do A, B, and C. Then I'm going to find the 3 separate areas and add them up. Okay, so let's have a look at what the dimensions are for each of those bits. So each of them is a rectangle. Area A is 9 centimetres here, and let's see how long it is. Well, it's got the 8 bit here, the 7 bit here, and the 10 bit here. So it's 8 plus 7 plus 10, which gives me 25. So the area of that rectangle will be 9 times 25, which is 250 take away 25, so that's 225 centimetres squared. B has got also a length of 9, but it's got a width of 7 plus the 10 from here. So the area here is going to be 9 times 17. I've got leftover working from the last shape, sorry about that. So 9 17s is what we've got to work out here. That gives me 90 plus 63, 153 centimetres squared. Lastly, we've got area C, which is the little rectangle on the top. That's the easiest one, so that's got dimensions 10 centimetres and 6 centimetres. So the area is equal to 10 times 6, which is 60 centimetres squared. So the total area is 225 plus 153 plus 60, which gives us, hopefully, the same thing that I got before. Let's see, 400, and it's going to end in an 8. Doing this very badly, aren't I? 200. Let's just think about it. 225 plus 153 gives me 378, plus 60 gives me 438 centimetres squared. Of course, guys, you can use your calculator for that. That's totally fine. I just want to highlight how nice it looks when you do set it out like this, right? It's really, really clear how this diagram links up to what you've written. So please, as you're starting to move through to solving harder problems, when you get past year 9, really think about how you're setting out helps people understand what you've done. Because as you know, especially if you're in Weka, I've said this lots and lots of times this year, maths is not about getting the right answer, right? It's about trying to tell a story through your working. So working really, really matters. Okay, that's the end of the sermon about working for this video. On to question 16. We've got a rectangular cake tin, and it's got dimensions 3 centimetres high by 20 centimetres long and 30 centimetres wide. What volume of cake mixture will the tin hold? So the first thing to check is that the units are the same in each case, and they are. So the volume is going to equal the length times the width times the depth. Oh, no, what's happened there? Right, something weird just happened. Sorry about that. So it's going to be 3 times 20 times 30, which is 600 times 3, so 1,800 cubic centimetres. If we were dealing with a liquid thing, it would be millilitres. Remember that 1 mil is equal to 1 cubic centimetre. Okay, so what volume will it hold? Well, it will hold this volume. Each spoonful of cake mix produces 100 cubic centimetres of cake. How many spoonfuls of cake mixture can be placed in the can? I think they mean tin. I don't know who wrote this question, but when I do baking, it doesn't go in a can. Never mind, it's still a good question. So what do I have to do? Well, I've got the total volume, 1,800 divided by 100. So it's a how many question. So 18 spoonfuls. if you don't eat any while you're making it. Right, on to the relational questions. And here it says clearly you have to show all working. Okay, Manu left for home at 20:45 hours on the 12th of April 2006, so 13 years ago. The trip home took him 245 minutes. When did he get home? So this is one where I do want to, you guessed it, use a number line. Okay, here's my starting point, 20:45 on the 12th of April. And the trip took him 245 minutes. So when I see that, I think in blocks of 60 minutes. So that's 4 hours plus 5 minutes. So I did that quickly because I thought, well, 4 60s gives me 240. Right, so let's see, where do I get to with 4 hours? Well, this time I don't think in 24-hour clock, maybe because I'm old. Maybe not. So if I add on 4 hours to 8:45, I get 12:45 a.m. and then I need 5 more minutes. Right, so that gets me to 12:50 a.m. So he arrived home, but that's the next day. So my answer would be 12:50 a.m. on the 13th of April. If you're going to write that in 24-hour clock, it would be 0050 on the 13th of April. As I said in the uni-structural questions, I always use a number line for questions about time, and just always remember that there are 60 minutes in an hour, so you don't work with 100 being your base unit anymore. Next question, find the perimeter of this shape. Well, this is one where we've got to be a little bit careful with what we've got. First thing is to get everything into the same units. And in here, we've got meters, centimeters, and millimeters. So I think I'm going to start by changing everything into centimeters. So 0.09 meters is equal to 9 centimeters. 18 millimeters is equal to 1.8 centimeters. 30 millimeters is equal to 3 centimeters. So I'm changing this one, and this one. And now I'm pretty good to go. So the perimeter, I'm just going to tick off the sides as I go. Well, the first one here is going to be 9 centimeters. And if you look over here, I've got exactly that same length with those 3 bits there. Okay, so it's 9 plus 9. So that's tick, tick, and tick. And then I've got some bits left to add in. I've got 12 here, so that's that one done. And then I've got 6 up here. And I'm told that this one here is 3. So adding those up, what's left? Well, now I've covered up all the dimensions. Let's clean it up. So the only thing I've got left to get into my perimeter calculation is this bit here. But you can see that this thing is 12, right? And this whole bit here is just 6. So this part of it is 3, so it's not drawn to scale, right? If this is 3, then that means that this bit here is 3, and this bit here is 3. So this bit here has got to be equal to 12 minus 3, which is 9. So just be careful when you get one with sticky outputs like this. You've got to make sure that you're not your brain might want to say that length is 6. My brain didn't think that was 9, but it is 9. Has to be. Okay, so now we finally need to get on with it and just add those numbers up. What do we get? Well, we get 9. 3 9s are 27. 36 and 12 gives me 48 centimeters. Now, I wasn't told what unit to use, so you could say 48 centimeters. What would some other good answers be? Well, we could do 480 millimeters, or we could do 0.48 meters. All of those are fine. Okay, relational question 3. Oh, this looks really awful, but it's not once you've had a good close look at the shape. The faces of the pyramid shown are all isosceles triangles, and we have to paint all the faces and the base. And we've got one pot of paint will cover this much area, 56 meters squared, and it costs $10. So how much does it cost to paint the pyramid? So first of all, we're going to say that area is equal to the base plus 4 times the triangles. Right, and the triangle areas are all the same. So let's draw out the triangle face, see what we've got. Well, they're all isosceles, so that's telling me this length here is 6 meters. And this length across here is 8 meters. So the triangle area is pretty easy to get. Area is equal to half times the base, which is 8, times 6, which is 24. And that's meters squared. And now we've got the base, which is a square base. So it's 8 times 8, which is 64. So my area is equal to 64 for the base plus 4 lots of 24. So 64 plus 96 gives me 160 meters squared. Right, so now we have to figure out how much paint we need. One pot of paint covers 56 meters squared and it costs $10. So first we're going to work out how many tins or number of pots of paint, and I'm going to underline that and put a colon, right? So this is making it really easy for the marker to see what I've done. The number of pots will be 160 divided by 56. Now what does that equal? Well, that equals 2.85 blah blah blah. So grab your calculator for that. But we can't buy 2.85 pots of paint. We need to buy 3 pots. So the last thing we work out is the cost. And the cost is 3 lots of $10, which is $30. So again, just highlighting how we want to see you setting this up. You're showing us all of the steps. So first you're explaining that you're finding the area. Then you're finding the number of pots of paint. And lastly, you're finding the cost. And if you can break the problem down like that, it will usually work out quite well. Okay, that's the hardest skill in these extended abstract and relational questions, is to split up what's being asked for into little manageable bits. Right, now question 4 is one where we're going to use the volume of a prism formula. Right, so let's go back to our formula sheet to just remember what that is. The volume of a prism is the cross-sectional area times the depth. So that's what we've got here. I'm going to do this in 2 bits. Makes it easier for my brain, right? So this first bit down here is just like a shoebox. This is a cuboid or a rectangular prism. And then I've got a triangular prism up on top. So splitting it up, volume equals cuboid plus triangular prism. The cuboid volume, everything's in the same unit, is 3.5 times 30 times 20, and that gives me 2,100 meters cubed. Triangular prism is equal to half the base, 20 times the height, 2 times the depth. So that gives me 600 meters cubed. So the total volume is going to equal those two added together, which gives me 2,700 meters cubed. And the last thing we're going to work out is that how many people can stay in the library without being deprived of oxygen. They each need 30 cubic meters of airspace. So people, underline, colon, 2,700 divided by 30 equals 90 people. Now I've got 30 seconds. I just want to look again at the triangular prism bit in case you didn't see how I did that. So let's get rid of all of this. Look, here's my base for the triangle here. Bad color pen. Let's do that one. So the base for the triangle's here, but we know that that's 20. The height is 2 meters. So we're going to do half the base times the height with those numbers. And then this length here is the depth, okay, and that's 30 meters. So that's where the 30 comes from in there. This bit is the area of the face, and this bit is the depth. All right, thanks for watching. Part 4 coming up soon.